Hello everyone and welcome back. So continuing on with our terrain manager. Lee, what do you got lined up in this video?
A whole bunch of stuff.
Yeah, I
Lots and
know.
lots
And
of stuff.
in
And it's,
preparing, you were concerning me. It sounded like we were going to be all over the place.
yeah, we really are going to be all over the place. And the problem is it's all over the place, but in little itty bitty pieces.
Ooh,
So unless we made like a whole bunch of minute and a half long videos,
right?
I'm going to be kind of all lumping it together
So
into
just a
one.
so I guess we can just throw out one of those quick disclaimers just to let everyone know that since you're changing stuff on the fly and you've got to go all over the place, that they just need to bear with you. That way it's not stressful and you can just relax and have a good time doing this.
Oh, I never get stressed.
Yeah, you stress? No.
Not, well, yeah, maybe when you start egging me on a bit, but
I never egg you on. What are you talking about? Start coding.
I got a video that I could pull up that can point out to the contrary, but
Hmm.
All right, so actually probably several dozen ones, but
Yeah, so what are we doing?
we are going to do some checks for our patches that we have loaded up. Basically, we need to look at what patches are there and make sure that those patches are still within the range of our hold range.
Hmm.
Otherwise, we're going to queue them up to be removed. We
Okay.
also want to check to make sure that those patches are going to be visible by the camera. And if they're not visible by the camera, we want to hide them. But to pull this off, we're going to have to add some stuff into the camera class itself. And then we're going to have to do some more work over here. And then I think we might do some similar stuff over in the patch builder to hide or to remove queued patches if they're no longer visible. So,
Okay.
like I said, a little bit of stuff everywhere.
Gotcha.
So, but we'll start off simply by creating a simple variable called offsets, and we're going to hold inside of there a whole bunch of vector2s that we're going to get by calling patches dot keys dot toArray. So basically, we're going to get all of the keys that are inside of our patches dictionary. The reason why I want to get this as an array is I want to reverse iterate through this array because we're going to potentially be removing patches out of this dictionary. And if we just try to iterate using a for each and removing, it will explode. So we're going to have to reverse iterate so we can remove without blowing up the enumeration.
Okay.
So let's do I can do this really. For tab, there we go. All right. Actually, I don't want that one either because I'm really lazy and I like hitting undo until I get exactly what I'm looking for. So like that. So now we can do offsets.length -1. So otherwise I'd probably mess something up and leave I++, and we all know that doesn't end well.
Right.
So then what I'm going to do is make a var position that's going to equal our offset sub I or element I. And then this is where we start doing our checks. First check is going to be if we're not in range. And what we're going to check for our range is our current patch location versus our position that we're getting. So we're going to compare our current position with the position we just got from the element that we're currently on.
Hmm.
And then the range that I want to compare against is going to be our hold range -1 divided by 2. So that should give us our hold range, and it's still not happy because it's going to say lack of precision. So there, I'll give us that. And I don't need a semicolon at the
No, you
end.
don't.
It's like going, there's something wrong with this. All right, now, if this is true, meaning we are not in range of our hold range, we're going to remove that patch. To remove the patch, we just say remove patch, and we say the position. The next thing is we're going to break out because we've just removed this patch,
Hmm.
and we're going to do some more checks after this. But if we've removed the patch, there's really no point of doing the rest of this part. But the other part of it is we're going to do some fairly hefty calculations in this update, meaning removing the patch is going to also do a whole bunch of work with the vertex cache when we get there. So I don't ever really want to remove more than one patch at a go. So I'm going to use the break completely out of this loop, get out of the update altogether, as opposed to continuing on and potentially removing multiple patches all in a single update.
Okay.
So that's why there's a break. All right. Now, this next condition is going to be the check to see whether or not we're visible by the camera, which means we need to go modify our camera real quick. So if I go to third person, go to our TP camera script, inside of here, I'm going to set up a new property that is going to be a public, and I'm going to make this static, mostly because there's only going to ever be really one camera that I'm going to have TP camera on. And I'm going to call, well, first of all, this is going to be of type planes, or hold on, it's an array of planes. So it's a plane array. That's kind of funny to say. And I'm going to call this frustum planes. Basically, what we're going to do is we're going to save the planes that make up the frustum of the camera. And there's a really handy dandy method that we're going to use to do this. So inside of late update, we're going to do all of our update stuff after our update position inside of late update. The last thing we're going to do excuse me, is get our planes. To get our planes, we're going to say frustum planes equals geometry utility dot calculate frustum planes, and then we pass in our camera. Luckily enough, that will be this camera, so we can just say camera, and that should give us the camera that this is attached to. I could also do, if I wasn't sure, I could do camera dot main or main camera. Either one will do the same thing. So you could use any one of the three, whatever makes you happy. So this will give us our frustum planes. Now we can go back to the TerrainManager, and inside of here, to do our check, we'll basically say two things. We're going to check our distance. We're going to basically say if vector distance vector2 dot distance, and we're going to compare our current position, so current patch location, and this position, and we're going to say, okay, if this is less than 1 or less than equal to 1, we definitely want this patch to be visible regardless of anything else I may say. So we'll go ahead and do enable patch, and we pass in this position. Now, else, if for some reason we're greater than 2, or greater than 1, not 2, we'll go ahead and we'll do another check. Now this check is going to basically say, well, let's do an if, else if, and this will say if geometry utility dot test plane AABB, and we're going to pass in our third person camera dot frustum planes, so that'll pass in our array of planes, and then we will also send in the bounds. So this will be our patch. So we get patches. We need element position dot mesh dot, well, I can do dot mesh, oh come on, dot mesh, what, oh that's right, this is a patch, mesh dot mesh renderer dot bounds. I'll get there. So Again, no semicolon at the end of this. So basically, this is saying, hey, check to make sure that whatever we got intersects with one of our planes. If it does, we're going to get true. If it doesn't, we're going to get false. So if it does, we're going to go ahead and set our enable patch. So we'll go and say enable patch position. Now, this gets fun because I'm going to have to put this inside of brackets so I can get my else ifs correct. Else, we're going to disable the patch. And look, ReSharper didn't say, hey, I know a simpler way to make this all work. So it agrees with me. It's like, oh, wow, I don't know how you can make that better. But so basically, all we're doing is ensuring that if we are really close to the player's position, that patch is always going to be visible. If we're beyond that range, we're going to test against our frustum of our camera. If we're inside the frustum of the camera, we're going to make sure that that patch is visible. If it's not, we will disable it. And that all happens after we remove the patch.
Cool.
So if I go ahead and build this out, and I go ahead and run, cross my fingers.
Let's see, what's that down at the bottom?
That would be.
Never mind. Yeah, I see. It's the...
Yeah, well, that's a different problem.
No, I just saw it.
Yeah.
Little blurry on my side.
Yeah, well, the problem that I'm running is I really need to probably load in our scene.
The scene? Yeah.
Yeah. And then try running it. Just a guess. That's just that visual
Yep,
thing.
I know.
All right, so there's our patches, which is kind of what we expect to see. Now, if I turn on our camera so we can see the frustum, and I start spinning around, you notice all the patches that aren't in the camera are disappearing.
Mm-hmm.
Except the ones that are really close. These
Right.
are all the ones that are the equal. So, but now we got another problem. That shouldn't be popping up. So we are getting a null reference from this somehow. So why are we getting this, and which one is it going to be? Unity, there we go. So we are getting it. Sure, not set to instance. And all of them are at the same line, at line 72. Now what's interesting is there's two possibilities for null, but which one is it going to be? So there's... Okay, let's do one other thing. And go back to camera. Here. Nope. This one. There we go. All right. I think what's happening is because this is happening potentially in an update before the camera can ever get a chance to get a hold of the frustum planes and populate it. So what I'm going to do is go frustum planes equals a new plane with 6 elements. Give that a shot. If not, then it's probably the other one. It's kind of funny how that works. If it's not one, it's the other. Well, I guess it wasn't that one. So, but I only got 2 this time. Let's move that over to the side. Spin the camera around, see what happens. Nope, starting to get some more. All right, now.
Yeah, I think you only had 2 last time when you just hit start and did not rotate the camera.
Gotcha. Why'd I hit play again?
I'm not really sure.
I thought it'd be fun.
Okay.
All right, let's go back to code. Not that one. This one. All right. That's still good to do. Make sure that's not null anyways. Now let's do some more checks. So another if. So mesh should not be 0. Well, technically it could still be 0 here if the patch builder hasn't done its job too. So if does not equal null. Then we can go ahead and do this stuff. Oh, wasn't that nice? It wrapped it for me too. Alright, so let's give this one a shot. See, and if we were doing the over-the-shoulder stuff, people would get to see me to do this 10, 12 hours a day. Alright, is normalized. What in the world? Oh, come on. Alright, fine. Camera. If you're going to be that way, I'll get rid of that one. TerrainManager. So if our TP camera dot fresh from planes does not equal null and our mesh doesn't equal null. It's got to work sooner or later. I'm running out of permutations to run through this thing. Uh-oh, look at that. No errors.
Good deal.
Yay. And we can run around. Oh, hold up. Let's do something. Character. 30.
Very nice.
So, for those of you that were worried about not having the Pro feature, as long as you use something like this, you could still make it work. So, but, you know, I don't think you're going to be doing any of this. Yeah.
No.
Nope. So you're not going to be doing it.
In reality, neither are we.
This is true. It was just a proof of concept to see how fast we could go before we started making things get flaky.
Right.
So, and then, so we've got that in place. Let's go ahead and go to our config file as well. I'm going to go back over here, this version. Let's go to our config. I'm going to up our numbers now for our interest area. Let's go to 21 and let's say 31. Now, something else I should warn you when we start playing with this particular build, which is another reason why I like the other solution a little bit better, is when we start getting into the processes here, and you start looking at Unity, I'm not even running, and we're already using almost a half a gig of memory, and commit size we are. So as we start expanding our world and we start running these tests, we can run around fine, but it's still got a memory leak in the editor, and eventually it will cause the editor to crash. So you'll end up having to occasionally just stop the editor to and restart it to continue working. But for some reason it doesn't do that in the standalone. So it's just a memory leak that we've got internal. So now we can see we've got a fairly larger distance, but it's taking longer for us to draw everything in as well.
Right.
But once it loads in, it's fairly nice and fast. And you can just barely catch the patches on the outside. So that would be the our frustum test. So it's just lagging a little bit, which is why we're catching that. So you could do another variation if that was unacceptable. We could switch up that test with a test similar to what we're doing for the creation of the patches and use the dot product to expand the edges out. It's just going to be a matter of what you find acceptable. Let's see how well it'll hold at, what did we say? 40? Was that the one we did before?
I thought you did 30, but
I did 30 in this test. I meant during the other preview. No,
yeah.
no, that was actually only, I think, 10 or 15 when you said I was really doing 40 miles an hour.
Yeah. Overall, seems like
But,
it's holding up pretty good, though.
yeah, so a little bit on the glitchiness on the side there.
Yeah.
So we could probably clean that up with the different test. Matter of fact, if we got some time, I'll show you that. So if I jump over into code and we decide that TerrainManager, this particular test isn't cutting it for us. We want something a little bit more flexible. We can take this and we can drop this here. And let's take this test and replace it for this one. All right, so now I spin around, and this one's even worse than before. So
Yeah, it is.
let's go ahead and widen our range down to, say, 0.2. And when I do it, we should see a wider range. Well, that tends to be slower. Oh, I'm still not loading them in. Hold on, there we go. So those were the load-in ones.
Right.
So,
Cool.
but we can see I'm almost at a 90 degree. So what you can do is tweak that second number, that point, the number I changed from 0.5 to 0.2, and tweak it until you get something that is working well on your machine. So then we've got all that, and I'm curious to see how fast I can go before this breaks apart. So it's still loading those patches. So it looks like we're breaking at about 70. So that's getting caught up. Let's do 60. Also, let me drop this in. So I'm still not happy with it missing patches. Where is that patch missing from? So it's this corner patch. All right, let's fix that too, because that's going to be really annoying. And code this one. All right, this is going to be our initial test here. We're going to change this less than equals to 1 patch to be 2 on each one of these. This will give us a little bit farther range surrounding our character when we drop in. All right, and we're running, after all loaded in, about 300 frames, a little over 300 frames a second, 134 draw calls. So spin around, load everything up. So everything's fine there. Take our character. But, whoa, definitely not. Not gonna do the test on that one. All right, let's see what happens this time. So a couple of flickers on the edges every once in a while. I think that might also be because I'm so far out on the camera. But what you can do is you can play with those numbers. The minimum distance that patches have to show. Yeah, it's still breaking at about 70. Let's try 60. Basically, at 70, we're traveling so fast that the patch cleanup can't keep up. So 60 seems to be pretty much on the verge of it. 50 probably will give us enough margin of error that we can work with it. So yeah, we're holding the fairly well at 50.
Yeah.
So if we did a quick check on that, my handy dandy calculator, let's go to velocity, meters a second versus miles per hour. So we're saying 50. You're getting about 112 miles an hour out of that.
Not bad.
So yeah, not bad for something that is being all instantiated on the fly. So you also have to remember, this is without the vertex cache in place, and this is without the persistent storage system in place. So what you're seeing is all this data is being generated in real time.
Mm-hmm.
So as we're going through these patches, all these are being created from the train generator, and there's no multi-threading in this system. So
Yeah,
this is just all the improvements from refining the code.
that's pretty incredible.
So this should alleviate all the worries of people who were fretting over not having Pro. So you just won't have the massive worlds that we had before, but it doesn't mean that you can't get a fairly large world still going. So okay, that's cool. And what I want to do is we'll come back in the next video,
Mm-hmm.
and then I want to go through the patch builder a second time, and we're going to put in the culling code, the code that's going to basically check to see if the camera is still near where the player is and that those patches are still in the view of the camera to create them, as opposed to constantly instead of just constantly loading up the whole queue. Because part of the problem that we're experiencing with lag here was the fact that we were spinning the camera so fast
Mm-hmm.
that when we got to the new areas, it was still drawing the patches that we were just looking at a few seconds ago.
Right.
So all those had to load, and it was trying to play catch up the whole time we were running around and spinning the camera.
Okay. All right, so is that going to wrap this one up?
Yep.
Awesome. All right, everyone. Thank you very much, and we will see you in the next video.